In this video for section 8.3, we're going to introduce a new special type of sequence called a geometric sequence. In a geometric sequence, each term is obtained by multiplying the previous term by a fixed number. So in an arithmetic sequence, we are adding or subtracting by a constant each time. In a geometric sequence, we are multiplying by a constant, and that constant is called a common ratio. So looking at example 1, it says to write the first 6 terms of the geometric sequence with first term 6 and common ratio 1/3. So A1 is 6, A2 is 6 times 1/3, which is 2. A3 would be 2 times 1/3, which is 2/3. A4 would be 2/3 times 1/3. And remember, when you're multiplying fractions, you're multiplying across. So tops times the tops and bottoms times the bottoms. That would be 2/9. You are going to have to put the answers in as fractions when you do the homework. They're not going to accept a decimal approximation for these. A5 would be 2/9 times 1/3, which would be 2/27. And A6 would be 2/27 times 1/3, which would be 2/81. So next you should look at checkpoint number 1. Do this in your notes, check your answers, and then move on with the video. Now we have a formula for the general term of a geometric sequence, just like we had a formula for the general term of an arithmetic sequence. For a geometric sequence, the formula is this: a sub n equals a sub 1 times r to the n-1 power, where r is the common ratio. Be careful when you're doing the order of operations here, because you need to remember to do the exponent, r to the n-1, before multiplying. So example 2 says to find the 8th term of the geometric sequence whose first term is -4 and whose common ratio is -2. So if I use the general term formula, a sub 8 equals a sub 1, which is -4, the first term, times r, which is -2, raised to the n-1 power. N is 8, so this is going to be 8 minus 1. Now, if you're doing this on a calculator and typing it in all at once, you should be able to get the answer from this. If you're doing it by hand, I would do 8 minus 1 first and get 7. Now I need to do -2 to the 7th power, and that would be -128. And then multiply -4 times -128, and that equals 512. So 512 is my 8th term. Next, you should look at checkpoint number 2. Do this in your notes, check your answer, and then move on with the video. Next, we're going to look at example 3. They're giving us a table that shows the population of the United States from the years 2000 to 2010. And the first question says to write, we're actually going to skip part A, but for part B, it says to write the general term for the geometric sequence modeling the population of the United States in millions n years after 1999. So I'm going to replace my years here with n, what the n is going to be. So in the year 2000, that's 1 year after 1999. So this is 1. This is going to be my second term. This is going to be my third term, etc. So for my general term, I need 2 things. I need the first term A1, and I need the common ratio R. A1 is easy. My first term here is 281.4. To get R, if they're giving me these sequence values, which is really what this is here, these are the sequence values, what I do is I divide two consecutive sequence values. So just like with the arithmetic sequence, I need to figure out what I'm adding each time to get the next term. In this case, I need to figure out what I'm multiplying by each time to get the next term. And I don't know off the top of my head, what do I multiply by 281.4 to get 284? So what I need to do in order to figure that out is divide those. Sometimes you might know off the top of your head what it's going to be. Other times you might have to actually divide it on a calculator. This is a dividing it on a calculator situation. If I divide on a calculator, I get 1.009. And if I pick any two of these when I divide them, I should get 1.009. Now, it could be slightly off for some of them due to rounding, but it will be about 1.009. So then, to write my general term, a sub n equals a sub 1, 281.4, times r, 1.009, to the n minus 1 power. Part C says to project the populations in millions for the year 2020. So what I need to do is figure out for this one, the year 2020 means n equals what? Well, it might be tempting to say 20, but if I look up here at the values that I've kind of crossed off, but like if you look at the year here, the n value is one more than the number after the 2000 part. So 2007 is 8, 2008 is 9, 2009 is 10. So 2020 is going to be n equals 21. So that's what I would plug in for n. So a sub 21 equals 281.4 times 1.009 to the 21 minus 1 power. And to do this by hand, I would do 21 minus 1 first, then do 1.009 to that power, and then multiply by 281.4, or type this all into your calculator, and you should get 336.6. So next you should look at checkpoint number 3. Do this in your notes, check your answer, and then move on to the homework.